In Java, we have three different basic types of loops that we can create. We have a while loop, a do while loop, and a for loop. They're all a little bit different. They all have certain situations where they work better or worse than the others, but we want to know all three. Right now, we're going to take a look at how to create a while loop. And a while loop, if you remember back to the video on basic loop concepts, is going to be the type of loop in Java where we check first and then run our loop body. So that would be this flow chart here that we talked about in the other video. It's a good first loop to learn, so I always recommend that students start with this one. And let's go ahead and jump into Java and see how this works. All right, I have a real basic program here for us to start with. This one just asks the user, what is the best community college in Arizona? It gets a response from them. And if the response is not equal to the correct answer, it's just going to output wrong. And so I have a constant up here that we can check against to see if we've got the right answer. A couple quick things here just to remind you. But when we are comparing strings in Java, we can't use equals equals or not equal, the bang equal symbol. We have to use the dot equals method. That is different than some other programming languages that you might use, and it's easy to forget, and I forget just like everybody else does. But I remembered this time, so let's go ahead and try this program out and just make sure it works. Oh, the other thing I was going to point out is that strings in these string comparisons in Java are case sensitive, right? So if I come in here and I say EMCC in lowercase letters, it says that that's wrong. If I type in something completely wrong, obviously that's wrong. And to get it right, I have to type in EMCC, all capital letters, just like that. So far so good. This isn't the most exciting program in the world, but I'm just going to draw attention to the fact that the way our if statement works is it evaluates this Boolean expression. If that Boolean expression comes back true, it runs the block of code, and then it moves on with program execution from there. A while loop is actually very similar to that because if you remember our little flow chart, it's going to check a Boolean expression just like an if statement. If it comes back true, it's going to run a block of code just like an if statement. The difference is it's then going to bounce back and take another look at that Boolean expression. So if we just change that word while, the word if to the word while, and execute this again, I'm going to get it right the first time. So EMCC, no change, right? It just goes on and completes execution of the program. But if I get it wrong, oh, so it is printing out the word wrong over and over and over again. This is an infinite loop, right? This means this is a loop that will go on forever because this Boolean expression is always going to come back as true. First of all, let's stop this. There are a couple ways we can stop this in VS Code. You could just kill the whole terminal down there, but what Visual Studio Code does while your code is running, you've never noticed this before because until now your programs have finished running really quickly, but there is a stop button up here. So I can just stop that and we're good to go. So let's talk about this infinite loop for a moment. What has happened is that we have created a loop that has a control variable, and the control variable is called response. And so we're checking against that after, with really before every iteration. And it's never changing. So there's never a chance for this to ever become false, so to speak. So what we really need to do is we need to change that response variable and give the user another chance. And so I'm going to just steal that line of code from up there. And I'm going to say that, change that to say wrong, try again. What is the best community college in Arizona? Now, in the back of your mind, especially if you're an experienced programmer, especially if you're an experienced programmer, you might be thinking, oh, well, now we're sort of duplicating this. Why, we could use, you said there was a type of loop that is execute first and then check, and that might be more appropriate for this. And that's true, and we will get there, but our focus right now is on a while loop, so we're going to stick with this for a moment. Let's go ahead and run this version. And again, I will get it correct. This time I'll get it correct the first time. Program finishes executing, no problem. Let's get it incorrect and see if we still have that infinite loop. Wrong, try again. What's the best community college in Arizona? So far, so good. It's at least stopping to prompt me again. I'll get it wrong one more time. And now I'll get it correct. There we go. It seems to have worked. There is a little bit of this that's kind of unsatisfying, and that is that the program just sort of stops. And so let's just add a line of code here that acknowledges that they got it right. Oops. System out print line. And we'll try it one more time just to get that little satisfying message at the end. So we'll get it wrong, and we'll say EMCC. There we go. That looks good. Let's talk a little bit about how we did this. And so there are three components to a loop that I want you to think about when you are creating a loop. Three different things that we did. So the first thing we did was we initialized a control variable. So our control variable in this case is called response. Then we evaluated a Boolean expression. Okay. And that was the while statement there. I talked at length about that. And then we updated our control variable. So I want you to remember those three kind of pieces, or those three components. The other thing I want to point out here before we talk about some errors you might make is that this would be categorized as an indefinite loop. At the time we start iterating, we don't know how many times we're going to have to iterate in order to finish this process or finish this loop, right? Because we don't know how many guesses it's going to take for this person to get it correct. They may have gotten it right before the loop even starts, and so this, if they typed in capital EMCC on line 13 here, when we get down to evaluate this Boolean expression, it's going to come back false, which I know is slightly confusing because getting the answer correct means that the expression is false. But it comes back false and it just skips. Okay, so when we have this kind of while loop where we check first and then execute the code block, it's possible that we have 0 iterations, right? And that's what happens if we get it right the first time. But if they do get it wrong and we start iterating this loop, we don't know. They might get it right the next time. It may take them 10 times. They may never get it right, which would be sad for them to not know the best college in Arizona, but it's possible. So this is what we mean when we say an indefinite loop. At the time we start executing it, we don't know how many iterations we are going to run. The other thing I want to take a moment to linger on here before we move on is a couple potential errors here that you might have. One of them, well, actually, we've already made one of them. We had that infinite loop when we started, and I just want to talk about that in these terms now. We had that control variable response, and we never updated it. So I do think I kind of mentioned that already. I guess I don't need to repeat myself. But a common mistake that students make, especially if they're beginners, you've kind of finally gotten in the habit of typing a semicolon at the end of all your lines here. So you may type a semicolon at the end of your while statement, right? Just sort of out of habit. And I want you to see what happens when you run that. I'm going to kind of move this up here so we can see a little better. That's the best community college in Arizona. I'm going to type that in wrong. We are actually stuck in another infinite loop, right? And it's kind of an odd one to understand. Visual Studio, incidentally, will still let me type down there, but that's just because that's the way Visual Studio works. I have my Visual Studio set up to automatically format my code every time I hit save. And so it has recognized, the formatting in here has recognized that there's something kind of fishy going on. You're not supposed to have a semicolon at the end of a while statement, so it is assuming that was meant to be on the next line. And white space in Java doesn't matter, so having it on line 17 here is equivalent to having it on the end of line 16. And a semicolon in Java just by itself essentially means do nothing, right? So we have written a loop that says, as long as the answer is wrong, do nothing. And so that's what it was doing. It was just sitting there doing nothing. And it will sit there and do that forever. By the way, I think we can also hit Control C on your keyboard to break out of that as well. So that's a real common mistake and another easy way to get yourself into an infinite loop. But that gives us a nice basic example of how a while loop works. Let's take a look at how to create a definite loop using the while loop structure. All right, so here we're just going to create a simple loop that counts from 1 to 10. And to remind us of the 3 components that we need to have, I've kind of pre-slugged those reminders in here. So we're going to have a loop that counts from 1 to 10. We're going to need a control variable to keep track of those iterations. And it's going to be an integer. It's going to be a counter, if you remember back to that the other video. And in fact, I'm just going to call it counter. And I need to set it to an initial value. I'm going to set it to 0 for now. And you're going to see you may already have kind of alarm bells going off. Why'd you set it to 0? We're going to experiment with some things and just see how they work here as we go. Now we need to check the Boolean expression. And again, it's just like an if statement, except it's while instead. So while counter is less than 10, and again, some alarm bells might be going off, but while counter is less than 10, that's our Boolean expression there. It's going to be either true or false. Then we're going to print that out. And I've learned from my past mistake that I also need to update the control variable. Now that update needs to happen inside the loop, otherwise we'll never get to it, right? So let's update the control variable. And what I need to do is I need to say that counter equals counter plus 1. We'll talk about that statement and some different ways we can write it here in a moment. But let's test what we have so far. Not bad. It's hard to see probably on the video, but it started counting at 0 and it stopped after it printed out 9. So it's close. It iterated the correct number of times. It's just that it started at the wrong number and ended one number too soon. So we need to talk about how to fix that. There are going to be a couple different ways we can do that, including some more clever ways than what I'm going to do now. But the starting point is really easy. I can change that initial value for counter. And so that's an important thing to remember. We don't always want our loops to start at 0 or 1 or whatever. We might need to start at some other number. That's part of our initialization, right? I've initialized my control variable to where I want it to start. And let's run it again, see what we get. We're still stopping at 9, but we are starting at 1, so we have solved that problem. Let's take a look at this Boolean expression. While the counter is less than 10, run this code. So at the first iteration, or the first time we evaluate this expression, 1 is less than 10, so it comes back true. Let's run it, and we're going to add 1 onto it. Now we're equal to 2. Go back up, evaluate it again. 2 is less than 10, run the code, add 1 onto it, now we're at 3. And it's going to keep going. We won't talk through every single iteration, but what happens when we get to 8, and now we add 1 onto it, it's 9. Okay, 9 is less than 10, run the code, add 1 to the variable, it's now 10. We've printed out the number 9, our variable is now 10. So now we got to jump back up here. 10 is less than 10. That is not true, that's false. So it skips down to here and it continues executing from there. So you got to think carefully about that Boolean expression that you write. There are several different ways to solve this, and honestly, it probably doesn't matter which one you use. There's a little bit of kind of style to that, like some people just tend to write their loops in some ways and some don't. So for example, some people don't like to have um, we'll just say if the counter is, while the counter is less than or equal to 10. So let's going to run that again. And it worked because when it gets up here, we're at 9, we print out 9, we add 1 to it, and it's 10. So we come up here now, 10 is less than or equal to 10. That comes back true. That works. We run it one more time. Now, at the end of this, when it's all said and done, counter is actually equal to 11, but it doesn't matter because we're done printing out, right? So that's one common solution to that. I think I tend to usually write it that way. But another thing that people do is they just increment, they just increase that sort of boundary by 1. So they say, as long as the counter is less than 11, then we're going to execute this code. Let's try that. And it works the same way, right? We say, we print out 9, make it 10, comes up here, 10's less than 11, but now we increase it to 11 and we get up here, we've turned it up to 11 just like they did in Spinal Tap, and 11 is not less than 11. So I know this is getting into the weeds a little bit, but it's just like with our if statements, that logic is so important and it's so easy to make mistakes, right? And so another common mistake you might make is putting that sign the wrong way. I can't tell you how many times I've done that. What happens if we make that mistake? Well, that was weird. Nothing happened. Something happened. Here's what. We set the counter to 10. That's our initial value. While counter is greater than 11, that comes back false. So we just skip down here. 0 iterations, right? This is a check first, then run kind of a loop. If we fail that first check, we never even run. Sometimes that's what we want, right? Like if they got the answer right on that previous example. But in this case, it's incorrect. We really want to run that at least one. Okay, I paused the video and I backed us up to where we first started, our first version of this loop that incorrectly started at 0 and ended at 9. And I mentioned that there are some potentially clever solutions to this. And it has to do with how we update this control variable. So the first one doesn't really fix this, but it's worth pointing out that most programmers, once they have a little bit of experience, aren't going to write this line of code that way. They're probably going to do something like plus equals 1, right? Or they're says add 1 onto whatever the previous value was, or they're going to use what we call the increment operator, which is plus plus, okay? And plus plus essentially just adds 1 onto whatever value is there. And so if I run that, okay, and programmers not liking to type a lot, being a common theme among us, most programmers are going to write it this way, right? This little increment operator is pretty cool because one of the things I can do with it is I could put it right there in my print line statement. Okay, and let's see what that does. It still works, okay? And now here's where we can start to get fancy. I'm just moving my comment because now the line of code that increments or that updates that control variable is actually the system out print line. We call this a postfix increment, and I love to be nerdy about my words here, but what that means is that when it sees this, the runtime goes out and checks memory to see what value is in counter, and it puts it in there and it executes this line of code, and then after it's put it in there, it adds 1 onto it. We can also do that increment as a prefix, and what that says is add 1 to it first and then stick the value in where it belongs. So let's run that. And that one gives us a true or a correct count from 1 to 10, right? So that's just a clever little thing or a useful little thing sometimes, especially I know some people, as you get more advanced or you learn more, you're always looking for like just more simple or more efficient ways to do things. There's nothing inherently more efficient about how this runs, incidentally, but in writing your code, some people just like that kind of stuff. It doesn't really matter. They are all functionally you can use whichever method works best for your specific loop that you are writing. All right, so that's a good example of a definite loop and some different ways we can kind of work with that. Let's take a look at what's maybe a little more of a, it's not going to be advanced, but another way we can use loops to kind of solve some problems. Okay, I've set up a little problem that will require a loop to solve. So what we're going to do is we're going to ask the user to type in a number, and then we're going to create a multiplication table, a simple multiplication table, by multiplying that times every number from 20 to 100, right? It's enough repetitions that we certainly wouldn't want to do this by hand or anything like that. All right, so I've got little placeholders for my pieces that we need. So first I need a control variable. This is essentially going to be a counter again, right? This is a counter controlled loop. And this time, since I'm multiplying numbers from 20 to 100, I might as well start there. And then we're going to evaluate our Boolean expression. That's going to be our while statement. So while that counter is less than, and this time I've learned my lesson, less than or equal to 100, right? And we're going to do whatever we need to do inside of our loop. And so this is going to be, first I need to so I'm going to multiply the counter times multiplier is what I called the user's input. So I need to multiply those two together and save that in a variable. Again, you could possibly skip the variable for beginners, and especially in Java, I like to put this in a variable, not just in the print line statement. So answer equals counter times multiplier. And now we're going to print that out. And I'm going to make it, I will give it a little bit of kind of user interface here. So I'm going to say counter, I'm going to say, it's going to say 20 times 7 equals or whatever. So the code looks a little bit confusing with all these pluses and all of that, but let's say multiplier equals that, and then the answer. Let's see if I got all that correct. Okay, let's give this a shot and see how it works. So I'll type in the number 3. And we do have an error. I have made an infinite loop, and hopefully you are already understanding what the problem is, right? We have a placeholder that says we need to update our control variable, but we never did it. So let's go ahead and we're going to do, and I could use one, I'm going to put it down here sort of separately. I just showed a moment ago how we could do it cleverly kind of inside here or something like that, but I want to keep them separate because I'm trying to emphasize these 3 separate points that we are going to need to do. So let's see if I have fixed it. 3. It's not an infinite loop, so that's a good sign. I'll scroll up and see if we started at 20. 20 times 3 is 60, 21 times 3 is 63, and so on. We should get down to 300 at the bottom. And that looks like it's good. Let's do one more simple one to just sort of wrap up how you might use these to solve problems. Okay, so there are obviously all kinds of things that you can do with while loops, and we're just barely scratching the surface, but that does show the syntax and the basic idea of how it works, so we'll go ahead and stop there. Reach out if you have any questions.